Yeah, Assalamualaikum warahmatullahi wabarakatuh. My name is Wafi Uzair bin Zainuddin, metric number 1040. Today, me and my friend Zahidi will present to everyone our mini project proposal for subject internet-based controller. Here we go. As the introduction. Nowadays, every human being requires electrical power in order to live comfortably. The consumption of energy is rising in daily life, while other energy sources are depreciating day by day. As a result, other power sources are need to meet the demand for power. There are two ways to generate electricity, one from non-renewable source and the other from renewable source. One non-renewable sources such as fossil fuel, coal, natural gas, and nuclear fuel are not originated by default after use, while renewable sources such as solar, geothermal, wind, and the tidal energy can be used again and again without depreciating. As a result, solar power is regarded as a long-term power source. As consequence, it is considered a long-term power source. Solar power has increased in popularity around the world because it is plentiful and has a low environmental impact. However, as conversion technology improves, solar power generation become more affordable. The monitoring of solar system at the customer level is currently needed to make them available. In the coming year, more suitable energy source could fully replace non-renewable energy source. Solar photovoltaic system generate enough power on a regular basis. As a result, it is essential to monitor its output in real time. The Internet of Things technology offers a solution for real-time tracking of solar parameters. An Internet of Things, or we call it as an IoT, computer is one that can connect with both of the machine and the cloud. We were able to wireless retrieve data from the cloud due to the use of IoT. In any solar power generation system, monitoring system parameter is important. Present, voltage and temperature which are critical solar photovoltaic device parameters are sensed by severe sensor in real-time monitoring. Remote control of solar photovoltaic system face numerous challenges, including tracking panel voltage, current, and temperature, as well as synchronizing real-time data from the solar system. The node MCU is used for this, and it is communicate with the machine and transfer data over the favorite IoT cloud, the system that we use for coding the IoT. The proposed system is scalable because it connects the photovoltaic to a cloud server to a high-tech general packet radio service, or as a singkatan we call it GPRS. Here we go to the problem statement. For this proposal, we have found a three problem that we found. First problem is the consumption power is increasing everyday life at the same time. Other energy sources are decreasing day by day. So, what is the way to reduce the usage of the energy? The second problem is our world have suffered because of the pollution caused by the energy. Can the solar power reduce the amount of pollution caused by energy that we use today? The third problem statement, the solar panel that people use today is not monitoring by any system, so they can never know how much the power solar panel to generate the whole day. From this problem, what are the best way to solve this problem? So as we can see, this is the problem that we can find uh, before the using of the solar power. So this project objective is to stabilize between the usage renewable source and non-renewable source. So the non-renewable sorcerer can maintain for our next generation. The second one is uh, we we create such a project because the amount of pollution caused by the other sorcerers, the non-renewable sorcerers, are very extremely not good. So, solar power has proven that it have a minimal impact toward the environment. And the last one is this project is to track the amount of energy that has been kept by the batteries in solar power. So we will know how much is need to generate the power for one whole day.
Okay, I'm Ahmad Zahidi bin Abdul Latif. Yeah, I will show you for class the system prototype. In the prototype system, no MCU ESP32 is used here to interfacing with solar panel and the sensor. Okay, kat sini saya nak terangkan yang NOD MCU ESP is use ni adalah untuk dia akan bersama dengan solar panel untuk kesan cahaya matahari. Okay. INA 219 is a sensor that used for detecting the voltage, current and power. Okay, fungsi INA 219 ni adalah untuk kita kesan current, voltage dengan power yang diserap oleh solar panel. Okay, seterusnya, the DHT11 is a sensor that used to detect the temperature and humidity, and BH1750 work as light sensor. Okay. Kat sini DHT11 ni dia sensor sebagai detect suhu dan kelembapan, manakala BH1750 ni pula dia mengesan menjadi cahaya sensor cahaya. So all the data then transmitted to remote server with the help of an MCU, which is Wi-Fi gateway, transfer the data to cloud. The cloud data is retrieved by use the application. Okay. This block diagram, this PV station ni adalah solar dia. Ni yang kesan current, power dengan voltage. Ni yang kesan kelembapan suhu dan sensor cahaya tu. The purpose of the mini project is to monitoring the solar panel using IoT is shown in the block diagram. The INA 219 sensor is monitored by using the sensor mount on PV panel and power conditioning unit PCU. Power is obtained by using mathematical formulation. For sensing the voltage, the INA 219 is in methodology. We can see that the power flow in the model is explained in that the solar radiance energy sunlight from the source sun is stored by the battery inside the solar panel, and then the solar panel convert the solar power into electrical energy. Okay, kat sini diterangkan macam mana cahaya daripada lampu tu dapat kuasa daripada mana. Jadi solar panel ni akan serap cahaya dan INA 219 ni akan convertkan bekalan yang diserap oleh solar panel tu untuk jadi kuasa untuk jadikan bekalan lampu untuk bercahaya pada waktu malam. Jadi dekat solar panel ni akan disambungkan kepada bateri lah. So bateri ni akan simpan tenaga cahaya yang diserap oleh solar panel. The electrical energy then sensed by the INA 219 for measuring the voltage with the help of voltage divider principle and current produced by the solar panel. They also censored by the INA 219, and temperature of heat energy available of fall on the solar panel is tracked by the DHT11. On the collect data of voltage, current and temperature sensor is then fed to node MCU, which convert the signal into digital using serial interface, and MCU act as a gateway and sends this data over the cloud server and then access via user over the application. So this cost estimation. So ada 7 barang: solar panel, modul, INA 219, DHT11, BH1750, ESP32, board, ESP controller, favorite IoT. Okay, favorite IoT ni kira macam dia punya sistem dekat dalam Google. So yang sebab tu dia RM0, dan yang lain ni adalah barang-barang yang untuk buat litar lah. Jadi solar panel ni 100, INA ni 20, DHT 10 dengan BH150, ESP32 board RM75, controller RM100, dan total sekali adalah RM315. Okey, dari situ tamatlah perbincangan yang Wafid dan saya buat ni. Dan terima kasih.